Alright, today we're going to look at our Advanced Algebra study guide for our final. This is going to cover the first page of problems, how to work through them, and then in the next video we'll look at the second page. In this problem, the first problem, talking about volume, the most important thing to understand is the formula for volume is length times width times height. So we need to figure out what our three sides, three dimensions are going to be, and then from there we'll just plug them in, and then we'll use multiplication, distribution, the box method, and full method to complete our problem. So if you read the problem, it tells us that the length is 5 more than the width. So that means we're looking at the width plus 5, or 5 plus the width, however you'd like to write that out. The height is 3 times the width, and subtract 2 because it's 3, w minus 2. And then we can safely assume that the width is equal to itself. You don't have to use w's, you could use x's if you'd like. It doesn't matter, just as long as all your variables are the same, that way we can multiply them. So if we plug those into our equation, this is what we're going to be left with. Now you can take that w and you can distribute it to the left, or you can distribute it to the right. In this case we're going to distribute it to the right. Only distribute it to one side, not both. When you distribute that, you're left with 3w squared minus 2w, and from there what we want to do is we want to do the full method on that. You could also do the box method. For this video we're going to look at the full, so the first term times the first term, outside, inside, and last. Key here is we're going to line up the two like terms together, the 2w squares, because those are going to be the only two that we can combine, and make sure that your answer is written from the highest exponent down to the lowest. So our final answer would be 3w cubed plus 13w squared minus 10w. Our perimeter, the formula for perimeter of a rectangle is 2l plus 2w. You could also draw yourself a picture knowing that rectangular sides, opposite sides are congruent. So we know our length and our width from the problem, 2x minus 3 and 4x plus 2. So we can just plug those into our equation. And from here, all you would need to do is distribute the 2. So you get 4x minus 6, distribute the 2 again, get 8x plus 4, and then combine your like terms, 4x plus 8x and negative 6 plus 4, and we will get a final answer. Let's go back and see what our final answer is, of 12x minus 2. You could also draw a picture and get the same thing. You could get the sides. You'd have 2 sides that were 2x minus 3, 2 sides that were 4x plus 2, and then you could just add up all your like terms that way as well. Either way, you're going to end up with an answer of 12x minus 2. In this next problem, we're given a square that has an area of 25 inches squared. One thing we know about the square is that all the sides are equal, so that means that each side has to have a length of 5 inches, because 5 times 5 is 25. So therefore we know each side is 5 inches. In the problem, it tells us to decrease each side by 2. So you take one side that's 5, you subtract 2 from that, and your new side is going to be 3 inches. So if we plug that in, and our question asks us to find the new area, be careful with the wording here, understand what you're looking for. It asks us to find the new area. That requires us to find the new sides, which we found is 3. So 3 times 3 would give us a new area of 9 inches squared. When looking at a polynomial long division, you got to make sure there's a couple things. You got to have all the terms, they got to be in order. So that means your highest exponent down to your constant. So 5, 4, 3, 2, 1, and then one without the variable, or 3, 2, 1, whatever it is. Anything that's missing, you got to represent it with a 0. So if you're missing an x squared, an x cubed, you got to put in there 0, whatever you're missing, as a placeholder. And that's really just going to keep us organized and keep everything in order. Alright, so if you look on our problem, you see that we're missing the squared term. So we're going to have 0x squared as the squared term. Remember, whatever is first in your problem, whatever's before the division sign, that goes inside the radical bar. Whatever is second or whatever division, that's what goes on the outside. So on the outside, we're going to have x squared plus x plus 1. Remember, the same rules apply for what goes on the outside. If you're missing a variable in there, you also got to have a 0 for that one, which you'll see in the next problem after that. Then essentially all we're going to do is we're going to compare the first two terms. So we're going to compare 4x squared to x squared, and essentially what we're doing is we're just dividing those two terms. So what that means is that you're going to divide 4 divided by 1. There's a 1 in front of that x squared, so 4 divided by 1 is 4. And then you're going to subtract your exponent. So x4 minus x2, 4 minus 2 is 2. And then you're going to put 4x squared up at the top. That's the reason why we have the 0x squared, is to keep everything in order and organized. Then from there, you're going to distribute that to everything on the left side. So multiply it over there by everything. When you do that, this is what you get your answer in green. Make sure you subtract that, and when you subtract that, you're really distributing a negative, so that means all the signs inside will change, which is going to cancel out your first two terms. Combine your like terms here, so 2x cubed minus 4x cubed is going to be negative 2x cubed. 0 minus 4 is negative 4x squared, and then drop down your negative x. And then from there, you're just going to repeat that process over and over until there's nothing left to bring down. Alright, so we get down here to 3x plus 10. That's going to be our remainder. Remember, the remainder, you just write that as a fraction above what you divided by. So since we divided by a squared plus x plus 1, that's going to go on bottom. And then that would be our final answer to the long division problem. Rational zeros. When you're finding rational zeros, you're looking for whole numbers, or you're looking for fractions whose decimals end or repeat. So like 1/2, the decimal is 0.5, that ends. 1/3, you're going to get a bunch. You're going to get a 0.3, 3333333, that repeats. So anything like that are rational zeros. Anything other than that would be considered irrational, and we're not going to consider those into our answers. All right, so if we want to find all the rational zeros, the first thing we got to remember is we got to remember P over Q. Okay, so P over Q is going to give us the possible set of rational zeros. So according to this problem, P is always the constant. Okay. So you're going to look at the factors of the last number or the constant, which is going to be 6. Q is the factors of the first number or our lead coefficient. So if we list out the factors of 6, that's 1, 2, 3, and 6. The factors of Q would just be 1. Anything over 1 is itself. So our list of possible zeros would be positive and negative 1, 2, 3, and 6. Now from that list, you're going to pick one, and you're going to substitute it in for 0 in your calculator. All right? So you're going to take one of those numbers, plug it in your calculator everywhere there's an x, and what you're looking for, we're looking for an answer of 0. And if we get an answer of 0, I'm going to use that number for synthetic division. Okay? So we're going to use that for synthetic division. Alright, so if you plug that in your calculator, you find that you're going to get 1 will give us an answer of 0. So remember, synthetic division, you only use the coefficients. Same thing, if you're missing something, you got to put in a 0. And then our rules of synthetic division is you drop down the first number. We're going to multiply what's on the outside, so 1 times 1 is 1, that comes to the inside. Add what's on the inside and repeat that process until there's nothing left to bring down. You go through there and we get a remainder of 0, which basically just tells us that what we typed in our calculator is correct. Alright, so we know that 1, 0 is an answer of 1. And remember, every time you do synthetic division, you drop the degree 1 time. And basically all you're going to do is you're going to repeat this process until you found all the zeros, or all the rational zeros. So take the same process with the calculator. You'll find that negative 2 also gives you an answer of 0, so we use negative 2 for synthetic division. We get a remainder of 0, so we're good. And when we get our final answer on this one, we're going to have x squared plus 2x minus 3. Now here's where you can factor it. The whole purpose of synthetic division is to get it down to x squared, because x squared allows us to factor and then get our zeros from our factor. So what multiplies the negative 3 that's going to add to positive 2, not negative, positive? And so our answer there is going to be x plus 3 and x minus 1. Remember, these are just factors. We have to set those equal to 0 and solve them, or essentially just take the opposite sign of them. So when you do that, you get that x is negative 3, x is 1, and x are the two zeros from that. So our final answer, we'd have 2 zeros at 1. Okay, that is possible. We'd have 1 at negative 3 and then 1 at negative 2, and those would be your 4 zeros. In order to graph higher order polynomials, you got to have 4 things. You got to have the zeros, the multiplicity of each zero, your y-intercept, and your end behavior. So we're given this right here, negative 3 times x plus 4 times x minus 1 times x plus 2. Remember, anything with an x represents a 0, so that first -3 is not a 0. Alright, everything with an x is, and basically all you're going to do is going to take the opposite sign of that. So our zeros are going to be -4, +1, and -2. And we get that from looking inside the parentheses, take the opposite sign. The multiplicity is essentially looking at what is the exponent of each 0. Since there's not one written, we understand it to be a multiplicity of 1. There's an exponent of 1. So for every single one of those zeros, the multiplicity is 1. And remember, multiplicity tells you how does the 0 or how does the graph react at a 0, how does it interact. 1 tells you that it goes through it, 2 tells you that it bumps at that 0, and then the multiplicity of 3 tells you there's a hiccup there. To find the y-intercept, basically type in the function in your calculator, replace each x with 0. So if you type that in exactly how it is, we're going to replace each x with 0. We get an answer of a y-intercept at 24. In behavior, you need to refer to the chart that's in your notes. In behavior is degree, and lead coefficient, you look for odd or even degree, positive or negative lead coefficient, then that tells you how your in behavior is. Once again, look at the chart in your notes. For this case, we have an odd degree because if you add up the multiplicity, 1 + 1 + 1 is 3. That's an odd number. The -3 out front is our lead coefficient, therefore it's negative. So our graph is going to have the left arm up and the right arm down. Alright, since we're just sketching this thing, we're going to, it's going to be a very rough sketch. You need to be, a little bit more accurate. Make sure these things look nice and neat. The first thing you want to do is you want to graph your zeros, so -4, -2, and 1. Since those are x's, they need to be on the x-axis. The next thing you need to do, plot your y-intercept. That's another point. So these are the 4 points. These are the 4 parts of the graph that our graph needs to touch. It needs to either go through, bump, or hiccup at our zeros, and it definitely needs to cross the y-intercept. With a multiplicity of 1, we know it's going to go through all of those zeros. Next thing, go ahead and draw in your in behavior, because now you have a starting point and you have a finishing point, so it kind of gives you an idea of where you need to go with this thing. And then from there, just make sure the multiplicity tells you that it goes through each one of those points. So go through each one of them, -4, -2, cross your y-intercept, and then cross your last 0 at 1, and we've connected our in behavior. It connected our ends, and that will be our final answer. Alright, graphing radicals. There's 2 types of radicals we're going to look at on this worksheet or this study guide. One's a cube root. Essentially, you make an XY table, 3 negative numbers, 0, and 3 positive numbers. You can determine the 3 negative numbers. You can determine 3 positive. They can be the same. They can be different, but we want to use 3 of each. A cube root you can take the negative of, okay? So basically what we're going to do here is we're going to take those values for x, we're going to plug those into our function, okay? And then whatever we get as an answer, whatever our calculator evaluates it at, that's going to be our y-coordinate. Alright, so here's our function that we're given in the first problem. Once again, I'm just going to use the same ones I used earlier with -5, -3, -1, so on and so forth. So remember, x is what you substitute in for x in the calculator and evaluate it, okay? And then y is the answer you get once you type that in and substitute in. Alright, so if I plug in -5 first in there to x, -5 minus 2. Now I'm going to work it out like by hand and show you what it would be. You need to kind of work it out similarly in your calculator and make sure you're coming up with this same answer. So for the first one, you should get 0.08, something very close to that, okay? Just go in and repeat that process, and you should be coming up with answers that are very similar to this. And so there's our XY table. Remember the X and Y. Now we have a coordinate system, coordinate points to plug onto our graph, to plot on our graph, and then we'll have our final answer. So once again, this is going to be a very rough sketch. Make sure yours looks a little bit more accurate, a little bit more nice and neat than this. Very rough sketch. Just want to kind of give you an idea of how this thing should look. So there's your, remember the cube root kind of sort of like an S-type curve to it. Make sure that you understand that your graph should look very, very similar to this, although yours should be a little bit more accurate than mine. Alright, a square root function, we can't just go plugging in simply because you can't evaluate a square root at a negative number. So what we want to do is we're going to set the inside equal to 0. We're going to solve for x. We're going to use the answer we get for x, and then the next 4 numbers after that for our XY table. So if this is our function, okay,
What's inside the radical is x plus 2, so we're going to set that equal to 0. I get x by itself. That is the first number I'm going to use on my xy table, and I'm just going to pick the first 4 numbers after that. So negative 1, 0, 1, and 2. I'm going to do the same thing we did with the cube root function. Okay? I'm going to calculate this thing out, evaluate it, and your table should be very, very close to that. Okay? Once again, here's a very rough sketch. Yours should be a lot more accurate than mine. Now, make sure you understand that with a square root function, it does not continue on forever. It's got to have a stopping point because you have to stop evaluating at some point based on what's going to make the inside negative. All right, that's the end for part 1. Make sure you're working through the rest of the problems on that front page. We'll cover the ones that weren't covered in this video in class, and part 2 will be up sometime this week.